Hello everyone, welcome back to our digital VLSI channel. I hope you guys are doing well. Today I am going to discuss about how to design 4x1 multiplexer using 2x1 multiplexer. You might be wondering how we can build a 4x1 multiplexer using lower order multiplexer, that is 2x1 multiplexer. Well, it's actually quite straightforward, and I will also be sharing the Verilog code for it. Now let's get started. Here our required design is 4x1. So number of input lines is equal to 4. So now we have to divide 4 by 2. So that is equal to 2. So in the first line we required 2x1 multiplexer, and again we need to divide this 2 by 2, that is equal to 1. In the second line we need 2x1 multiplexer. If you add these two, so we will get 3. Total we required 3 2x1 multiplexer. In the first line we need 2x1 multiplexer. In the second line we need 1x1 multiplexer. Now let's draw the hardware circuit. So this is 2x1 multiplexer, and this is another 2x1 multiplexer. Here the input lines are I0, I1, I2, I3. The output of these two multiplexers we are going to connect to another multiplexer. Here selection input is S0, and here also a selection input is S0, and here S1. So here internal wires I'm gonna assume as Y0, Y1. Output of this multiplexer is Y. So now let's write the truth table S1, S0, Y. So here we have two selection inputs. So four possible combinations: 0 0, 0 1, 1 0, 1 1. If selection input S1 S0 is equal to 0 0, I0 is connected to the output. Next I1, I2, I3. And this is the truth table. So here the first 2x1 multiplexer, here this is the first 2x1 multiplexer, this is second, and this is the third one. First 2x1 multiplexer selects one of two input signals, that is I0, I1, based on the control signal S0. The second 2x1 multiplexer selects one of two input signals, that is I2, I3, based on the same selection input, that is S0. The third 2x1 multiplexer selects one of the two output signals from the previous multiplexers, that is Y0, Y1, based on the control signal S1. By combining these three 2x1 multiplexers, we can create a 4x1 multiplexer that can select one of four input signals, that is I0, I1, I2, I3, based on the two control signals, that is S0, S1. Now let's see here. So let's see whether the circuit is going to work or not. So here S1, what is the S1 selection input here? 0. And what is the S0 here also 0 and here also 0. So here S0 is equal to 0. That means I0 is connected. I0 is selected here. Here I2 will get selected. So here S1 is equal to 0. So I0. So I0, this I0 is transferred to the output Y. Now let's check the other inputs. Suppose if S1 is equal to 1 and S0 is equal to 1, and here also here S0 is equal to 1, so I1 will get selected, and here S0 is equal to 1, I2 will get selected. So here S1 is equal to 1, so I2 is selected. Oh, sorry, here I3, S0 means here I3. So here S1 is equal to 1 means I3 is transferred to the output Y. See, as you can see, we have effectively created a 4x1 multiplexer using lower order multiplexer, that is 2x1 multiplexer. I hope you guys understood the concept clearly. Now I'm going to show you how to write Verilog code for 4x1 multiplexer using 2x1 MUX. Here I am writing the code based on the hardware implementation of 4x1 MUX from 2x1 MUX instead of using case statement. First, let's start with the module MUX. Our required design is 4x1, so I'm first start with 4x1. So input, what are the inputs based on our hardware design? I0, I1, I2, I3. What are the selection inputs? S0, S1. Output, our final output is Y. Now what are the internal wires we assumed? So Y0 and Y1. Now we need to instantiate all our three 2x1 multiplexes. First MUX 2x1, some instance names M1. So inputs of the first multiplexer I0, I1. Selection input is S0. I0 is the output of the first multiplexer. Similarly for the second multiplexer, some instant name M2. Inputs I2, I3. Same selection input S0 and Y1 is the output. Similarly for the third multiplexer, Y0, Y1 are the inputs and S1 is the selection input and Y is the final output. Now end module. Next we need to write the code for 2x1 multiplexer. So mux underscore 2x1 input I0, I1. Selection input is S, output Y. So here I am using assign statement and also using ternary operator. If S is true, I0 is selected, otherwise I1 is the final output, and then finally end with end module. With this our design code is done. Now let's write the test bench. Module TB reg I0, I1, I2, I3, reg S0, S1, wire Y, mux underscore 4 cross 1 dut I0, I1, I2, I3, S0, S1, Y, initial, begin, repeat of 4, again begin, I0, I1, I2, I3, S0, S1, dollar random, and here I am giving some dollar hash time delay and dollar display. I1 is equal to percentage B, I2 is equal to percentage B, I3 is equal to percentage B, S0 is equal to percentage B, S1 is equal to percentage B, Y is equal to I0, I1, I2, I3, S0, S1, and then end, one more end with end module. Now let's run the code. Yeah, here is the simulation output. As you can see, when when S1 is equal to 0, S0 is equal to 0, I0 is connected to the output. Here I0 value is 1, so Y is equal to 1. Similarly, for S1 is equal to 1, S0 is equal to 0. That means 2. So I2 is equal to 1. This I2 is connected to the output. Yeah, that's it, guys. Thank you so much for watching. I hope this explanation helped you understand how to implement a 4x1 multiplexer using 3 2x1 multiplexers. Once again, thank you, and don't forget to like, share, and subscribe for more interesting videos. Thank you.